Hello everyone, welcome back to the another session in series of learning principles of programming languages. Today we'll be going to talk about general problem of describing syntax. This topic you will find in 8th topic of first unit. First unit is basically divided into two different splits, or you can say it is a parts. First chapter is all about preliminary concepts. Second chapter is about syntax and semantics. So we finished first part, which is preliminary concepts. Now from this video we'll start about syntax and semantics. Now let's get started. What do you mean by the syntax? Basically, when you wanted to write any program, you have to follow such a structure where all the lines are coded using that structure, correct? And you might have heard about the syntactical errors, because the error will be occurred when syntax it get violates, correct? Now the basic definition of syntax is what? The form or structure of the expression, statements and program units. So it is a structure what has to be followed. Example, if you take a statement in C programming, that variable assignment statement int a is equal to 10 semicolon, it is a structure what has to be followed by every programmer who is using C. If they fail to use one of the token over here, if they fail to keep the semicolon, then you will get a syntactical mistake or syntactical error. So finally, what do you mean by syntax? It's a form or the structure of the expression or statements and program unit. And semantic is what? The meaning of the expression. Whatever we wrote as the structure, semantic is what? It's a meaning of the expression, statement and program units. Now we'll see some example. The example is what? I'm giving an example for syntax. Later we'll give even the example for semantic, because both are what? Syntax is a structure, semantic is a meaning of the structure. Now I'll take some example. Simple C if statement will take an example. How if statement is written in C programming? If expression, true block, else false block, correct? This is what we used to write. Now this is what the structure what has to be followed. Now what is the semantic over here? If this expression is evaluated, then true block will get executed. If otherwise, if it is failed, if expression is failed, then false block is execute. So now syntax is this, semantic is the way of the execution or else the meaning of the statement what we are writing. And let's see about describing the syntax. Now how to describe a syntax? We need such things to describe the syntax. What we need is a sentence. A sentence is basically defined as a string of characters over sum of language is a set of sentences. A lexeme is what? It is the lowest level of syntactic unit of a language. We'll take some example. Example is what? Star plus equal to sum begin. These are what is called as lexemes. And a token is a category of lexemes units. And this question came in examination for 2 marks. The question is what? Let's suppose index is equal to 2 into count plus 17. Now identify the lexemes, identify the tokens. This is what the question given in the previous question paper. Now what are lexemes? Lexemes are lowest level syntactic unit. What is a token? It's a category of lexeme units, right? Now we'll write lexemes and tokens from the statement. Lexemes are index and equal to 2 into count plus 17 semicolon. These are what lexemes. Tokens are what? Identifier, because a token is a category of lexemes units. Now we have to differentiate all this categorical wise. Now index is what? It's an identifier. And equal to is what? It's an operator or else equal sign. And 2 is what? It is integer literal. Star is what? Operator, multiplication operator. Again count is what? Identifier. So tokens always will talk about the category and lexemes always will talk about the lowest level of syntactic unit. So I am telling once again, this question, direct question, has came 2 times in the examination paper, end semester examination. Now, the formal definitions of languages. There are 2 formal definitions in language. One is recognizer, the other one is generator. What do you mean by a recognizer? A recognition device reads input strings of the language and decide whether the input strings belongs to the language or not. Let's see the example. Syntax analysis of a compiler. Syntax analysis of a compiler. And what do you mean by generator? A device that generates sentences of a language. If the syntax of a particular sentence is correct, by comparing it to the structure of the generator. Now we'll talk about the most important part of syntax and semantic is what? To describe the syntax, we need a formal method. That's what? The formal language generation mechanisms are usually called grammars. So to describe this syntax, there is a formal method which is a grammar. Now that grammars are commonly used to describe the syntax of programming languages, and that grammar is BNF grammar. BNF grammar, and also you might have heard about this grammar, context free grammar, is a syntax description formalism that became the most widely used method for programming language syntax. Context free grammar developed by Noam Chomsky in mid of 1950s, who described 4 classes of generative devices or grammars that define 4 classes of languages. Context free and regular grammars are useful for describing the syntax of programming languages, and tokens of programming languages can be described by regular grammars. And we are not going to talk about this context free grammar. We are going to talk about BNF grammar. BNF basically stands for Backus nor form. Backus nor form. And it is introduced in 1959, invented by John Backus, and which is described in Algol 58 version. The syntax is what? BNF Backus nor form is equivalent to context free grammars used for describing the syntax. There are some fundamentals what we have to understand to write the syntax of using BNF grammar. Now the fundamental is what? In BNF, abstractions are used to represent classes of syntactic structures. They act like syntactic variables, which are also called as non-terminal symbols. Syntactic variables also called as non-terminal symbols. And these are appears in the form of abstraction. Abstraction can be derived. This abstraction is not the abstraction what we were going to talk in object oriented features. This was different. This is basically what you mean by abstraction. We'll hide something, right? Now we'll hide the derivation part of the non-terminal symbol in the form of abstraction. That we'll see. Let's see the example. If I wanted to write a rule in BNF, we used to say these are rules in BNF. The rule is what? Assignment in abstraction. So it is a non-terminal symbol which can get derived. So how can I write? Assignment variable is equal to expression. This is a rule. It describes the structure of an assignment statement. A rule in the left hand side, the abstraction being defined, and the right hand side consists of some mixture of tokens, lexemes and references to other abstractions, and consists of terminal and non-terminal symbols. Total is equal to sub 1 plus sub 2. A grammar is a finite non-empty set of rules, and the abstractions are called non-terminal symbols or simply non-terminals. So in other way you can also write the other example, that is statement is in the abstraction form. It is a non-terminal where you can derive it, or you can find the or statement for this abstraction. Statement, single statement, begin, statement list, end. So this is what, if you wanted to define any statement using BNF grammar, either you can write a single statement or else you can write multiple statements in between begin and end. So this is what fundamental idea of BNF grammar. And we'll discuss the next part, how you can write a program using in BNF grammar, how a grammar is basically defined. That part we'll see in the next video. Thank you all.